Hi, this is a Taylor series question from 2018, January question 3A. So the question states, where f of x equals cos x, show that the Taylor series expansion for f of x in powers of x minus pi over 2 is f of x equals cos x, which is equal to minus x minus pi over 2 over 1 factorial, plus x minus pi over 2 cubed over 3 factorial minus x minus pi over 2 to the power 5 over 5 factorial plus x minus pi over 2 to the power of 7 over 7 factorial plus dot dot dot. Right? So we have to show this part A. The biggest part of the question is we have to expand using the Taylor series formula. All right, part 2 is find the nth term of the series above, which I mightn't have time to do in this. And then part 3, use the first 4 terms in the series expansion for cos x to approximate cosine 3 pi over 4. Should be able to get that done. Now, on the back of the exam paper, you are given this. This is the Taylor series expansion, or that is the Taylor series expansion for f of x. Now, it is f of x equals f of a plus x minus a times f dashed a. So if you look at this here, x minus a here, and then we have to get our expansion about this x minus pi over 2. These are like the same, so that means that a must equal pi over 2. That's the first thing you need to identify as a. And then f dashed a, which is the first derivative of x, and then we sub in the value for a, and then again x minus a squared over 2 factorial, the second derivative, plus x minus a, in this case a is pi over 2, cubed over 3 factorial times f to the 3 of a. And this here general term here is what we would use for part 2. Okay, so let's just get started first of all. So we've identified that a is pi over 2 because it says here x minus pi over 2, and we can see here in our answer it's x minus pi over 2 as well. So when you've got x minus a, it's equivalent to x minus pi over 2, so a must be pi over 2. Right. Now you can see that according to the formula we have to have f of a, f dashed a, and so on. Now to be able to get the derivatives we have with a, we have to get the derivatives first of all with x, but first of all I'll just write down f of x, which is equal to cos x. Now we're going to have to differentiate cos x, and up here if f of x equals cos x, then f dashed x equals minus sine x. Righto? So that's the first derivative. If you differentiate cosine x, you will get minus sine x. The other thing to remember is that if you differentiate sine x, if you do the differentiation of sine x, you just get cosine x. There is no change from plus to minus when you're differentiating sine x, but there is a change from plus to minus, well, of sine when you're differentiating cosine x. Okay, so we have this is just f of x here equal to cosine x. The first derivative, f dashed x, is equal to differentiate cosine, you get minus sine. And these are in the tables, page 25 or 26. Differentiate this again a second time. Now, we go here. This formula or solution goes as far as x to the power x minus pi to the pi over 2 to the power 7, which means we have to go there right up to the 7th derivative. So x is second derivative. So we're differentiating sine x. So you have minus because there's a minus there, and you differentiate sine x, and that's just cosine x. There's no change from plus to minus of sine. Then the third derivative of x. Now we're going to differentiate cosine x, but it's a minus cosine. The minus stays, and you differentiate cosine, and you get minus sine. So a minus times a minus will give us plus, so that's just sine x. Now we're at the fourth derivative. We differentiate f to the 4 of x. We're going to differentiate sine x, and that's just cos x. And now we're actually back to the start, the same as it was the original value. We still have to do another couple of differentiations, but it's a repetition of what we've already done. Because f to the 5 of x is going to be differentiate cosine, you get minus sine. F to the 6 of x, differentiate minus sine, and you get minus, and you differentiate sine, you get cosine. And the last one, f to the 7 of x, the seventh derivative, is going to be minus, and differentiate cosine, you get sine. So cos minus sine minus sine, cos minus sine minus cos. Wait to see, differentiate cosine. That should be a plus. A minus times a minus, right. So it is a repeating pattern there, right. The thing is, according to the formula, it's not f dash to x and differentiations of f of x. It's actually a in the formula here, you see, f dash to a, f second dash to a. That means we're going to have to put in our value for a, which we discovered was pi over 2. So this is going to go in here. So if I was to differentiate this, just drop a line down there. Whoops, sorry about that. So now we're going to do f. Instead of x, we're going to put in a, which is pi over 2. F of pi over 2. That means we have to find cosine of pi over 2. Okay, now make sure your calculator's in radians for this. 9 marks for this question, actually. I'm going to write over it now, though. Because cosine of pi over 2 is equal to 0, right? And sine of pi over 2 is equal to 1. This will make it quicker to do, right? So we know that's going to be 0. Cosine pi over 2 is 0. Then the next one, f dash pi over 2. So all I'm doing is putting in pi over 2 where I had x. So it's going to be minus sine of pi over 2. Which is minus 1. That's an equals there. Then the next one, f double dash, no, f triple dash, now the third derivative. Oh no, the second derivative, sorry, double dash. F double dashed of pi over 2. Second derivative, it's going to be this one here, minus cosine, which is 0. And then the next one, f to the 3 of pi over 2 is going to be sine pi over 2, which is 1. So far we've got 0, minus 1, 0, 1. Now the fourth derivative is cosine pi over 2, which is 0. Now you might see a pattern now, f to the 5 of pi over 2. The fifth derivative is minus sine, which is going to be minus sine pi over 2, which is minus 1. So we've got 0, whoops, I forgot the minus in there, minus 1. 0 minus 1, and the next one, f to the 6 of x, the 6th of pi over 2, sorry, is going to be 0 because it's a cosine. And the last one, f, whoops, I'm running out of space here, f to the 7, I'll do it here, f to the 7 of pi over 2 is equal to sine of pi over 2, which we know is 1. So we have all the values for the f values now, and we have to put them into this formula. All right, so I'll just scroll down the page, hopefully have that formula in front of you somewhere. Here we go, because we're going to put these values here into the formula now for the f for the derivatives. All right, so if I write that out now, so f of x was equal to f of x, which is cosine x, was equal to, first of all, f of a, which was f of pi over 2, which was 0. That's this one here. Plus, maybe I'll actually just insert that formula again so you can see it. here. Right. Bring it up over there for now. A bit small, but maybe that's enough. Okay. So this is the formula. So f of a, which is f of pi over 2, was 0 plus x minus a. X minus a, which is x minus pi over 2. So every time we have an a now, we put in pi over 2. And then times f dashed a, which was the first one, which you've got minus 1 for, multiplied by minus 1. Plus the second one is x minus pi over 2 squared over 2 factorial times f dash dashed, which is 0. Sorry, 0. Okay. Plus then the next one, so it's multiplied by 0 there, which makes it 0. X minus pi over 2 cubed over 3 factorial times f to the 3 of pi over 2, which is 1, plus x minus a, which is x minus pi over 2 to the power of 4 over 4 factorial, and f to the 4 was 0. So all the even powers will have zeros, right? The next one is x minus pi over 2 to the power of 5 over 5 factorial times f5 minus 1, nearly there, plus x minus pi over 2 to the power of 6 over 6 factorial. And we know that's multiplied by 0. And then the last one that we're going to do, x minus pi over 2 to the power of 7 over 7 factorial, and f7 was equal to 1 times 1, plus dot, 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 but we're not going any further than that. So basically we've done the bulk of that question now. We just have to tidy this up, right? So anything that's multiplied by 0 will be 0. So we can cancel out this one multiplied by 0, this one's multiplied by 0, and that one's multiplied by 0. And we have 0 to start, that goes. So now we can write f of x, which is cosine x, is equal to minus 1 times that. I can put the minus in front, minus x minus pi over 2. That's that. The next value that's non-zero is plus, and it's 1 times it, so it's just plus x minus pi over 2 cubed over 3 factorial. Then the next one is a 5, and it's multiplied by minus 1, so we have minus x minus pi over 2 to the power of 5 over 5 factorial. And the last we're doing is x minus pi over 2 to the power of 7 over 7 factorial. It's multiplied by 1, so that's fine, and the power of 6 was 0. And that is our series done, okay? That's part 1 done, okay? So, but the next thing is, I'm skipping part 2, but part 3 is f, we have to find, according to the question, we had to find cosine of 3 pi over 4. That means we look at this one here, and instead of putting in x, we put 3 pi over 4. So x is equal to 3 pi over 4. Now that means, to make it quick, I can do what's inside these brackets first, because x minus pi over 2, whoops, that's just one line there, x minus pi over 2 is equal to 3 pi over 4 minus pi over 2, which just gives me pi over 4. So what goes into the brackets can be pi over 4, so I can rewrite that as pi over 4. So then cosine 3 pi over 4 is equal to minus. So instead of this whole bracket, for the x is 3 pi over 4 minus pi over 2, that's